Latency makes unexpected changes in human performance and the game's difficulty. The most widely used method to compensate these latency effects is to rewind the time frame by the amount of latency and then determine the feedback on the basis of that point. Here, players experience a discrepancy between the perceived situation stemming from the local feedback and the feedback given by the compensated system. This is our method to compensate for latency effects. When there is no latency, the player input distribution is shown as above. With a certain amount of latency, player must prepare and execute the input earlier than when there is no latency. It is because the latency reduces the amount of time for players to observe the target's movement and has the effect of pushing the input distribution backward in time. For Flappy Bird, we demonstrate the geometric compensation of the latency effect. All other variables being kept constant to maintain temporal dynamics of the game, the vertical spacing for pillars were changed for different amount of latency. On successful geometric compensation, error rates of different latencies remain similar to each other.